Hello and welcome everybody, this is Roland Hartmann from graphicinmotion.com and it is tutorial time again. In this tutorial I will show you the new physical options in Stardust. We will take a look how we can set up some really cool physical particle simulations right inside After Effects using the Stardust plugin. So let's get started and jump right into After Effects. First of all, let's create a new composition, and in my case I will just use the HDTV 1080 preset and call this physics. And now I will create a new layer and call it Stardust. And I will apply the Stardust effect to this layer. So to get a quick physical setup, I will use a preset. And to open up a preset, we can simply click this Browse Presets here. And you see there's a folder that's called Physical. And if we open this up, then we have 3 basic dynamic setups. And if you open the MISC folder here, then you see we have a few more really in-depth and complex setups that explain nearly all the options that you have with physics. But for this basic tutorial, we will just use this dynamic setup here. And I will click Replace to replace the setup here in my node tree. So before I do any simulating or show you what this does, I will quickly go through the setup that we have here. So first of all, we have a basic emitter that is just emitting from a point and emitting 50 particles per second with a speed of 100. Then we have a particle node that is set to model, so it will create models. And then we have this model node here that applies a primitive, in this case a sphere, to these particles. And we have a material that is connected to our model. And then, of course, we have this new node here, and this is called the physical node. And this is directly linked to the particle. So this is the first rule that you can memorize, that if you want to create physical simulations, the physical node always has to be connected directly to the particle node. There is one exception, and we can take a look at this exception right here. This here is our floor. So this is just a model node that creates a 3D object directly without any emitter needed. And you see that here we also have a physical node, and this is directly connected to this model node. So if you use this setup where you just use a model node to create a 3D object, then you can connect the physical node directly to the model node. And then we have one more node here, and this is just a material node that is applying a material to our floor. Okay, so this is the setup that we have got, and now let's take a look what this setup does. And if I change this camera view now to custom view, then we can see what this does. You see we have a few particles emitting, and we have this floor, which is actually just a flat box. And of course we also have some lights in the scene. So if I play this now, if I create a RAM preview by pressing 0 on my keyboard, then you see nothing specifically physical happening. The particles are just emitting like standard particles. And this is because by default, the simulation, the physical simulation is not turned on. So let's take a look where we can turn on our physical simulation. And therefore we have to move to the Stardust Master settings right here. And you see here we have this physics tab now. And if we open this up, you see that there is a simulation and now it's set to off. If I turn this on now, you may get an error and it says that you have to save the project first. I already saved the project, so I did not get this message. But if you did not save your project, then now it's time to do this. And let me quickly explain why you need to save the project. Stardust creates a simulation, and this simulation is stored on your hard disk in a cache. And this cache will be created right beside your After Effects project or wherever you save it. So in my case, I already saved this to this path here. So just save your After Effects project file, and then you can turn the simulation on. Now, to create a simulation, you simply have to create a RAM preview. So just go to your composition and press 0 on your numpad or space, whatever you have set up to create a RAM preview. And now you see we have some physical things happening. So the particles are now falling down. They are colliding with our floor. They are colliding with each other, and they're rolling off our floor here. And then finally they will fall into the eternity of After Effects 3D space. So this is the setup that we have got, and let me change this a bit so that it's a little bit more practical for our preview here. I will just stop the emission at around 2 seconds. So we'll create a keyframe here and we'll stop this emission at 2 seconds. Okay, and now I will just make my composition 5 seconds long so that I do not have to recalculate the whole 10 seconds all the time. Okay, so let's take a look what we've got. You see that now for 2 seconds we are emitting particles, then the emission will stop and the particles will just fall down to the floor and spread. This is our simulation. Now let's take a look at the basic settings that we have in the physics tab. So in the physics tab, let me quickly stop the preview. First of all, we already talked about the simulation. Here we have 3 options: off, on, and freeze. I will talk about this option here a little bit later. Then we have the option to auto cache, and auto cache means that if this is turned on and you change some parameters that have an effect on physical simulations, Stardust will automatically just recalculate the whole cache. So if you use a bit of a more complex simulation, which will of course take more time to render or to simulate, then I would recommend to turn this off. And if this is turned off, then it will not auto cache. So you have to tell Stardust to recache. Now you see if I move my cursor here to this frame, which was not cached, the simulation breaks. And this is because Stardust just didn't create a simulation for this frame here. So to create a simulation when auto cache is turned off, you can either use this button here. This is the cache in out button, and if you press this, Stardust will just jump back to frame number 1 and create a simulation or a preview from frame 1 or frame 0, I should say, to the end of your work area. But you can also, of course, do this manually, so you do not have to use this button here. You can just put your time indicator to frame number 0 and then create a run preview, and it will create a simulation of the physics. So if I turn my auto cache on and I will jump with my time indicator to, let's say, around 6 seconds, then you see now the physical simulation is still intact because now it just recalculated the whole frames before, and we have a physical correct simulation right at this point. So in my case now for this tutorial, I will leave auto cache on all the time. The next option that we have here is the simulation quality, and if we change this to, for example, medium and take a look what this does and recalculate by just creating a run preview. Now let's take a look at these spheres, and you see suddenly not all of them are correctly bouncing. Some of them just fall through this floor, and this is because now the simulation is calculated not so accurately, and this has to do with the quality. So you can always come in here and change this. Of course, if the quality is set to lower values, the simulation will work faster. You will not realize this with a setup like this because this is, as I said, quite basic. But of course, if you have more complex setups and maybe also with other shapes of collision objects, then you might need to increase these values here to get physically accurate simulations. For this tutorial now, I will just keep using this high setting. The next option that we have here is gravity. Gravity, pretty self-explanatory. The higher you set this, the faster objects will fall, the higher the gravity is. Then we have world scale. World scale is also interesting. You can scale your physical world. So if I increase this to a value, let's say to 1000, and I will create a run preview, you will see that now the simulation looks totally different. And now all these forces are weaker, or the world is bigger. So it will just last longer until they fall down, and the whole simulation looks totally different. So if I do the opposite, if I decrease this to maybe, let's say, like 25, and then of course the whole world scale is smaller, all the forces will be way stronger, and you see what this does. Now the force from the emitter, because this is also a force that is calculated in the physical simulation, is way higher, and now the particles are spread further out and fall faster to the ground. So I will leave this at 100 for now. Then we have the margin threshold. The margin threshold is a value that determines a margin, and this has to do with collision calculation. I will not go into the details here. There is a recommendation that you leave this value at its standard value and don't change it until you need it. So I would recommend just leave it, and if you realize any problems with collision, then maybe you can try to change the size of the particles instead of the margin threshold, because this can lead to inaccurate or wrong simulations. Now we have the cache folder option, and here you can see where After Effects or where Stardust created your cache. And you can reset this, so you can choose another cache folder. And yeah, this is just the folder where Stardust saves the data for the physical simulations. So these are the basic physics master settings, and now let's take a look at the settings in the physical node. So these are the settings that you can specify for each physical object or particle in your scene. Now I'm here in this one. This is the physical particles, so maybe I will just rename this physical particles. And this here is my physical floor, so just that we know which we are talking about. Okay, now let's go to the physical particles and let's take a look how they are set up. You see we have a type, and in the type we have two options. We have dynamic and we have kinematic. The difference between dynamic and kinematic is dynamic means that these particles will interact with all other physical elements in the scene. And if I set them to kinematic, then they will have an effect on dynamic particles, but otherwise they will just behave totally normal. So if I take a look at my floor, and this is actually set to kinematic, you see that it will not react to gravity, it will not react to any physical forces that I apply. It's something like a collision object, you could call it. It's just behaving whatever you tell it, but it will not be affected by other particles or other physical effects, but it will have an effect on dynamic particles. So sounds a little bit complicated, but actually it's quite easy to use. So in our case, these particles are set to dynamic. That means they are bouncing around, they are reacting to forces, they are colliding with each other, and they are colliding with the kinematic object, which is our floor. The next point that we have is simulate using sphere. This has to do also with collision calculations. You have three options here. You have sphere, box, and model. If you use model, then Stardust will take a look at the model node. Whatever you have in here will be used to calculate collisions. You have to be a little bit careful whenever you can. Use sphere or box, because this improves the speed of calculations and of simulations quite a bit. If you're working with really detailed models, then this can get really slow and really heavy for your RAM. So in this case, if you want to use another shape than a box or a sphere, then I would recommend that for simulation purposes you use a really low poly model, and if your simulation is done, then you can exchange this with a higher detailed model. In this case, of course, we have sphere because our particles are spheres. Then we have the collide with option, and there you can change between all and kinematic. If all is set, then all these particles will collide with each other. And if I set it to kinematic and we take a look, then you will see, if you take a close look, that they will not any longer collide with each other. They will just run through each other, but they still collide with our kinematic floor. So this can also help to increase the speed of a simulation like this, but of course now you have no self-collision in your particles. So let's change this back to all again. Now we have these other options like friction, bounce, and mass. I think that this is also pretty self-explanatory if you're a little bit familiar with physical parameters. Friction means how fast a surface, or how slippery a surface is, and how much friction there is between the particles and the surface. So if you increase the friction here, let's increase this quite a bit to 80, and let's do the same for the floor, because here we have to take a look at both values actually. And now you will see that they will not spread out so far. So now they will stick more to the floor and will not roll so fast over this floor here. Then bounce is of course self-explanatory. If I increase this value here, then they will bounce around like crazy. So let's set it to 70. Let's create a new run preview. And you will see now this is way more bouncy, and now the particles are bouncing around. Okay, And then we have mass. Mass, of course, if an object has more mass, so if I set this to a really crazy value like 2000 and recalculate, or actually the maximum here is 1000. So let's set it to 1000 and recalculate this. Let's see what this does. Now they are way heavier, and you see that, yeah, now they're still bouncing around, but they're reacting quite differently because of the high mass they have got now. Okay, so these are the basic parameters that you can assign to each of your physical elements. I will set this back to 100, and then you have the option to damp the forces. There we have two different controls. We have a damp and we have a damp forces. A little bit difficult to explain the difference between them. Just quickly, you can just damp the forces overall using the damp forces for all the frames of the simulation, and damp just damps the forces of the current frame. The difference you have to try out whatever you need for your simulation, but let me just show you if I set this, for example, to 5, and then the simulation will look different because now the forces are damped, so that means they are not so strong. So my initial forces from the emitter are a little bit weaker, and also the collision forces and everything. You see that they're just not spreading out so far, and they're more falling to the ground and staying there, or bouncing around a little bit. So this is what the damp forces does. Then we have the option to randomize all of these values. So if I put this now to 100, it will create also an interesting look. So because now all these values will be randomized 100%. So also the mass, which actually creates the biggest difference here. Because of course, if the same force is applied to a very lightweight object or a very, very heavy object, it will react totally different. This is what's happening here. Now we have some very lightweight objects and some very heavy objects, and this is because, yeah, it's a little bit crazy, the result. But if you add a little bit of variation here, like 5 for example, then you can get a bit more organic results in your simulation. So the next option that we have here is static until hit, and this option will try to keep the particles static until they are hit by another particle, or in some cases particles will start moving when their neighbors are moving. But if we emit particles already with a certain speed, then this will have no real effect. And then we have another option that's very interesting, and we can limit the movement of these physical particles to a certain axis. So if we take a look and I say I only want them to move on, let's say, the X and Z axis. So if I activate this and resimulate, you will see what this does. Now they actually only spread out here, which makes not much sense in my case. So probably I should choose another axis. I should choose XY in this case. Now they will only fall down in one plane, and then they will kind of pile up here, and they will not distribute on the Z axis. And that's quite funny. You can create quite nice effects using this limitation here with the axes. So and these are the basic settings for physical particles in Stardust. You can also add forces to these physical particles now. So there is a new node that's called physical forces. And if I use this physical forces node and apply it or connect it to my physical particle node here, then I can apply forces to my physical simulation. For example, if I do not want these particles to just fall down, if I want to give them a little bit more speed in a certain direction, then I can do this. You can apply different kind of forces here. You can apply directional forces, spherical forces, noise forces, and path. So to check these out, I would recommend that you browse through all these other presets that I showed you before. You will probably find all of these in one of these examples. So in this case, I will just use a simple directional force. And I will give a little bit of velocity on X, so maybe let's say 30. And I will give a little bit of negative velocity on Y, and I will set this to -20. If we now calculate this, you will see what this does. My particles fly back or to the right and upwards. Makes not much sense in this case, but I can also limit the influence of this force to the lifespan of my particles. And if I do this, and I can do this by effect over life, then this will make a little bit more sense. So let's use a preset here, and actually I will use this fade out Bezier preset and apply it. And I will make it shorter. So we'll just bring these two in here a bit. so that the influence of my forces are really short, just in the beginning of the life of these particles. And if I calculate this now, you will see what this is doing. Now they are kind of flying into this direction, and then after a short period of time, the force influence dies or ends, and then the particles will just be influenced by gravity and will fall down and hit our floor. So it is pretty funny. And let me change one thing. I will just decrease the speed here a little bit. So let me just decrease the speed here to 50 of the emitter so that they do not fly around like crazy. Let me create a quick preview again. And now they are not spreading out so far. And I think that this looks a little bit better in my setup here. Okay, so let's say that this is exactly the simulation that I want to create. Maybe the X value is a little bit too much, so let's set this to maybe just 20 and this only to -15 so that they do not fly out so far. I want them to stay on my floor here actually. So let me just recalculate my simulation to see what they're doing. And I think that this looks quite nice. So let's say that this is my physical simulation that I want to work with. And to do that, I can now just cache the whole physical simulation, what I actually just did, because now I just rendered my whole work area. So that means that the simulation is now finished for these 5 seconds. And to work with this further now, we can use the so-called freeze option. And therefore we go back to our physics tab here in the Stardust master settings. And if I change this now from on to freeze, then Stardust will not recalculate any simulation. It will just use the simulation that is now saved in the cache. And now we can add other forces or other effects here. So for example, I can now add a replica effect. And if I add a replica now and just link this to my forces tab here, and let's see what we can do here. So let's create a few replicates here, so maybe 10 replicates, and I will just offset the angle on Y 36 degrees. And you see what I've got here now suddenly. So if I drag this, then you will see it even better. I just created 10 replicates and just distributed them around in a circle, so 36 degrees. And if we play this now, you see the simulation is exactly the same. So the simulation is stored in our cache, and now Stardust just uses this simulation and replicates it with the replica node. And now you see that I have this nice fountain-like setup here. And I can take this even further by maybe colorizing this now, and therefore I add a field node and just link it. And now we could use a map, and I want this to be a color map. I want to specify the size myself, and I want to make sure that it affects the color. I want to project on Y. And now let's take a look. I want to see my helper here. Therefore, I quickly go to the render settings and turn on my helpers. So draw helper. And now I have the size here of my field. And I want to change this a bit, because actually I want to make it bigger on Y, because this is the axis that I'm projecting to. So let's make it a bit bigger on Y, and let's see what this does. And maybe I will shift it a bit so that it is sitting on my floor more or less, like so. Looks quite good. And now I can apply a preset here, like an interesting one, maybe this one here. This will create an interesting look, interesting colors to my particles. Now let's turn off these helpers. Let's come in here a bit further. And create a final quick run preview. Okay, so this is it with this quick introduction to the physical options of Stardust. I would really recommend that you check out the other presets that are included here, because there you can learn even more and you can see what is possible using these physical simulations. It's really awesome. You can create really crazy stuff that was not possible inside After Effects before. And last but not least, I want to invite you to visit my website, which is www.graphicinmotion.com. There you can find all my After Effects templates. You can find a lot of After Effects tutorials and also a lot of Stardust tutorials. So check out the website, check out these tutorials. Thank you very much for watching, and I really hope to see you soon. Goodbye.